Welcome back. We're still in section 5.4. We're doing still those sum and difference formulas. All right, so now what we have is we can use these to derive other formulas involving these expressions. So like sine of theta plus n pi over 2, cosine theta plus n pi over 2, and so forth. We can use these to find different values and simplify. What we have here is cosine of u minus v. So keep in mind, cosine of u minus v. That's cosine of u, cosine v, plus the sine of u, sine of v. And that is on your sheet. So now u is 0, or theta, excuse me. So we have the cosine of theta, cosine of 3 pi over 2, it's a quadrant angle, plus the sine of theta, times the sine of 3 pi over 2. 3 pi over 2 is down here. That's at 0, negative 1. So our cosine of theta, sorry, that should say cosine of 3 pi over 2. Cosine theta, now the cosine of 3 pi over 2 is 0, plus the sine of theta times the sine of 3 pi over 2, that's our y, which is negative 1. Cosine of theta times 0 is 0, that's gone. So it's just sine of theta times negative 1, or negative sine theta. So that top expression is just equal to negative 1 times the sine of theta. Now, tangent of theta plus 3 pi. That's tangent of u plus v. So tangent of u plus v is the tangent of u plus the tangent of v over 1 minus the tangent of u times the tangent of v. So now what we have is the tangent of u, which is theta. So tangent theta plus the tangent of v, the tangent of 3 pi. 1 minus the tangent of u, which is the tangent of theta, times the tangent of 3 pi. So now 3 pi. 3 pi is 2 pi plus pi. So what we're doing is we're going around the unit circle one full time. That's the 2 pi. And pi is over here. So that's where 3 pi is located, is at this piece. And that's at negative 1, 0. Now the tangent is sine theta over the cosine of theta. That's y divided by x, and that's 0 divided by negative 1. So the tangent of 3 pi is 0. So now what we have is the tangent of theta plus the tangent of 3 pi, which is 0, over 1 minus the tangent of theta times 0. Tangent of theta plus 0, that's just the tangent of theta. And in the denominator, 1 minus tangent theta times 0 is 0. So it's the tangent of theta over 1, or the tangent of theta. So if you add 3 pi to your angle, you would just get whatever the tangent of theta is. And we just showed that using our sum and difference formulas. Problem number 10 is a solve problem. Now there's a little bit going on here. Notice it's sine of x plus pi over 2, and the sine of x, pi over 4, and sine of x minus a pi over 4. There's our u plus v and our u minus v. So we have here, for the sine of u plus v is sine u cosine v plus the cosine of u, cosine of u times the sine of v, plus. Now that gives us the sine of u cosine of v minus the cosine of u times the sine of v equals -1. So for the first part, sine of u. So it's kind of like two separate things here. Like pretend like there's a little like imaginary line for right now. So we have the sine of u. So the sine of x cosine of pi over 4 plus the cosine of x sine pi over 4. Now for the other expression, the sine of u, which is x cosine pi over 4 minus the cosine of x sine pi over 4. Now, we wanted to make sure we substitute everything in because we're not always going to have our u and v's be the same value. So that's why I did that. Now, if we look, I see a cosine of x and a sine of pi over 4, and I see a negative cosine of x sine of pi over 4. They cancel out. We can clean this up a little bit. Now, don't forget, the cosine of pi over 4. Pi over 4 is at root 2 over 2, root 2 over 2. So now we have, sine of x, cosine of pi over 4, and another sine of x, cosine of pi over 4. They're like terms. When we combine them, we have 2 sine of x cosine pi over 4 equaling -1. So that's 2 sine of x. Now the cosine of pi over 4 is our root 2 over 2 equals -1. The 2's cancel. So the sine of x times root 2 equals -1. And we want to isolate the sine of x. Divide both sides by root 2. So that gives us the sine of x equals -1 over root 2. So we rationalize, multiply by root 2 over root 2. You get the sine of x equals -root 2 over 2. Now, we're only solving between 0 and 2 pi. Sine is negative in quadrant 3 and quadrant 4. Sine is going to be root 2 over 2 when we have a pi over 4. Something pi over 4 and something pi over 4. Now the numerator that's going to get us into quadrant 3 and quadrant 4, to get us into quadrant 3, that's going to be a 5 pi over 4. To get us into quadrant 4, it's a 7 pi over 4. So x equals, since we're only between 0 and 2 pi, is 5 pi over 4 and 7 pi over 4. And there's our two solutions. Let's do another one on the next page. For number 11, all of the solutions. So we have that sine of u plus v, u minus v. Notice how u and v are not the same this time. So for sine of u plus v, that's that sine of u cosine v plus the cosine of u sine of v. That's for the first part. And then for sine of u minus v, it's sine u cosine v minus the cosine of u sine of v, and that's going to equal 1. So it's going to be for the first half, sine of x cosine of pi over 2, cosine of x sine of pi over 2, plus sine of x cosine of 3 pi over 2 minus the cosine of x sine of 3 pi over 2. Now looking at this, I'm not seeing a whole lot happening as far as canceling out yet. Now pi over 2 is up here. That's at 0, 1. 3 pi over 2 is at 0, negative 1. So for the sine of x, we can't do anything. Now the cosine of pi over 2 up here, that is 0. Cosine of x, now the sine of pi over 2 is 1. Sine of x, the cosine of 3 pi over 2 is down here, that's 0. Minus the cosine of x, now the sine of 3 pi over 2 is negative 1. And what's nice, sine of x times 0 is 0. Sine of x times 0 is 0. So we have the cosine of x, negative cosine of x times negative 1 becomes plus the cosine of x equals 1. So it gives me 2 cosine of x equals 1. Divide both sides by 2, cosine of x equals 1/2. Now we're positive. So cosine is positive in quadrant 1 and quadrant 4. Now, when our cosine, that's when our value of x is a positive 1/2. That's going to be at our pi over 3. To be in quadrant 1, it's a pi over 3. To be in quadrant 4, that is a 5 pi over 3. So there's our two solutions. X equals pi over 3 and 5 pi over 3. Okay, now, in problem number 12, we're given that sine of u is 5/13 and the cosine of v is negative 3/5. Now, we want these to both be into the same quadrant. So the only time when sine would be positive and cosine is negative is in quadrant 2. So I'm going to draw both of my triangles in quadrant 2. Let's call this angle U and this angle V. Now, we're given for U that the sine is 5/13. So the opposite is 5. The hypotenuse is 13. And using the Pythagorean theorem, you'll know that this third side is 12. And since it's in quadrant 2, it's a negative 12. For triangle V, the cosine adjacent over hypotenuse. The adjacent, negative 3, and the hypotenuse is always positive. It's a 5. Now, knowing that's a 3 and a 5, the other leg has to be a 4. You can use the Pythagorean theorem to find that. So now we're given to find the exact value of the cosine of u plus v. So that using our sum and difference, that's the cosine of u, cosine of v, minus the sine of u times the sine of v. Now, in the triangle where u is the angle, the cosine adjacent over hypotenuse, that's negative 12 over 13. Cosine v, now in that bottom triangle, cosine of v, we already knew that, that's negative 3/5, minus the sine of u, we know already is 5/13, that was given to us, times the sine of v. We're down here at the bottom triangle, the sine is opposite over hypotenuse, which is 4/5. So we multiply the fractions. Negative 12/13 times negative 3/5. Negative 12 times negative 3 is 36. 13 times 5 is 65. Minus 5 times 4 is 20 over 65. Luckily, we can combine them. We already have a common denominator. We get 16 over 65. And there's the exact value. 16 over 65. And let's do the same thing for problem number 13. Sine is negative, cosine is negative. The only place where that happens is in quadrant 3. Here's u. Here's v. So sine opposite over hypotenuse. 7, 25. The 7 has to be negative because because the hypotenuse is always positive. Using the Pythagorean theorem, the missing side would be a 24, but since we're in quadrant 3, it's a negative 24. For v, the cosine, the adjacent over hypotenuse, the adjacent is negative 4 and the hypotenuse is 5. Using the Pythagorean theorem, the opposite side has to be a negative 3. Notice how the legs are negative because we're in quadrant 3. Now, tangent of u minus v, that's the tangent of u minus the tangent of v over 1 plus tangent u tangent v. So we fill in our values. Now the tangent, opposite over adjacent. So tangent for triangle u, negative 7 over negative 24 is a positive 7 over 24 minus the tangent of v, which is negative 3 over negative 4, which is 3 over 4. All divided by 1 plus. Now the tangent of u, we already found, is 7 over 24 times the tangent of v, which is 3 over 4. We found those above. So now this is just a complex fraction. We need common denominator. Multiply the second fraction by 6 over 6. So 7 over 24 minus 18 over 24, which gives us 7 minus 18 is negative 11 over 24. Now in the denominator, it's 1, and we can simplify before we multiply. The 24 on the bottom, that's divisible by 3, you get 8. 3 on top is a 1. So you get 1 plus 7 over 32. Common denominator of 32, multiplied by 32 over 32. So you get 32 over 32 plus 7 over 32. So we have negative 11 over 24, all divided by 39 over 24. Now, fractions represent division. We don't divide fractions, we multiply by the reciprocal. Keep, change, flip. Negative 11 over 24 times the reciprocal, 24 over 30. Where did I get the 24? Excuse me. That should be a 32. 39 over 32. Excuse me on that. So it should be times 32 over 39. That would have worked out too nicely. So now we can simplify before we multiply. 24 and 32 are both divisible by 4. The 24 becomes a 6. The 32 becomes an 8. Oh, sorry. Actually, they're divisible by 8. That's even better. So that's a 3, and this is a 4. So we get negative 44 over 3 times 39, which is 117. And there's the exact value. Mostly just working with fractions there once you draw your triangle. All right. I will see you in the next video. Thank you and have a nice day.